In our menu destructor here, I'm going to do the opposite of loading in a texture. This is to prevent memory leaks. We can, I think it's destroy texture. SDL underscore destroy texture. This is just for good measure. Most of the time, these things will only be loaded in once, and they're going to stay in memory, and we're going to count on them being in the memory until the program shuts down. So this is not overly important in that case, but it's a good habit to remember to free up your textures, delete any dynamically allocated memory to prevent memory leaks. I feel like that is pretty much it for menu. So let's start on options. So let's go back to the game state header file. And we're just going to copy menu here. And we're going to change menu to options. So the downside to having the state machine is going to be, we are going to have a lot of repetitive code. That's really the only downside to it. And that's not really bad, it just seems like there's going to be a lot of stuff written more than once. And generally in programming, that means you're doing something inefficiently, but not always. And we can just accept that with the state machine. I'm going to go ahead and use the light bulb to create my constructor, destructor, and my virtual functions. If you hold down Control, you can click on one of your declarations and it will take you to the definition. What sort of things are we doing in the constructor? In menu, we're going to load in a background texture, and that's really all we're doing right there for the moment. So you can copy that code, bring it down here to options, paste it, and we'll change this to options, and then we can open up a paint program and create that image. Oh, and change your error from menu to options. Doing that 1280 by 720, I believe. Yeah. So that should be the resolution of your background image. So that should be good. And then for our update, we can copy the guts of menu. Paste that in the options update. So options is like its own, it's got its own main loop. It's got its own event handler. The event loop is there. It's also going to check for keyboard input. And we will clear the renderer, draw stuff, and present. So this is like, options will have its own main loop. Menu has its own main loop. This is just to get the base set up, and once it's set up and we can switch between states, we can modify menu to where we can access any other game state like most menus do. And then from options we can put in stuff to adjust volume or screen resolution, things like that. But for the setup, the initial setup is going to be very similar. So we want to change, actually background texture should still be good. Yes. I believe that's it. When we push down 1, instead of going to options, we want to go to menu. And for enter, what do we need to do on enter? Nothing.
What about the deconstructor?
The destructor. Destructor destroys a texture. Which is important. So drop that in there. All right, let's move over into Maine. We created a menu object here. We can change this to an options object. So I'm going to comment these two. Actually, I'm just going to delete those all together. And then we will bring in options. And instead of making it an object on the stack, we'll make it a pointer. Well, actually we don't want to do that just yet. We'll make it on the stack for now. Options.update. And run that, and you should see your options screen instead of the menu screen, and you should be able to push escape and exit. Okay, that didn't work, so we yours works? Oh, my computer's just still sick. All right, that works. That's good. Okay. So we need to move our objects. We want to move our objects out of Maine and put them someplace they can access each other, because from options we want to go to menu, and from menu we want to go to options, we might want to go to the level, we may want to go to the credits. So usually you want to access different things, and so each state will need access to the other states. And we can't do that if we leave it in Maine here. So let's get rid of that for now. Let's head back over to our game state header file.
You're going to create buttons.
Yeah, we will create buttons.
All right.
We're getting the mechanics set up, and then we'll put in the interface.
Oh, all right.
All right, in order to make all of these states accessible from any other state, I'm going to make these game state variables. How many menus do I want?
4.
What?
Not menus, but I was thinking tabs. Never mind.
How many main menus do we want?
1.
Just one. So what does that mean? How to make sure that happens? 'Cause every time we create a state, it's going to create all of these things for that state.
Make them static.
Make them static. We want background texture. Everybody needs their own background texture. That should be different, so that's not static. But for the game states themselves, I only want one. And for static variables, we have to initialize them in global space, so you can step over into your source file here, and right after we make the window and the renderer, we can say game state pointer menu equals new menu. Same thing for options. And then we can step over into Maine, and we should have access to those variables. You can say game state menu, but we don't necessarily want to do this. We need one more pointer here, and that is going to be the current state. I'm using long variable names just to cut down on confusion. I normally don't do that, but it's okay. What should this be?
Current string.
What are we doing here? What is the current game state? When the program starts.
We want to start on menu.
We want to start on menu. I believe that works. I don't, yeah, it seems to recognize it. I was wondering if I had put the scope resolution in front of it, but I think that's fine. All right, back in Maine, now we can say current game state, enter. We need the scope resolution here though, game state. We won't worry about exit just yet. And then this will happen in a loop. So we'll enter a state and then we'll call update, and that's where the main loop is for that state. So we'll hang out here until we need to change states. When we change states, we will leave update. This will loop here and we enter the next state. We'll change the current game state pointer to some other state. We'll enter that state, and then we'll update. We'll hang out there until we change again. Let's put a loop here. I'll make it a hard loop for now. We may want to come back and make that. We may want to come back and put a Boolean in here later on, but for now, this is fine. Now let's head back to game state CPP. We want to make it so that when we press 1, we change states. So I'm in the menu class. Don't lose your bearings here. Make sure you're in menu. The more states you add, the easier it is to get lost in the wrong class. We press 1. If we want to change states, what code am I writing here? Current. Game state equals what? Option. And then we need to get out of this loop. I can get out. The way I have this coded right now, normally you would put a bool here and then you would flip that to false. That would probably be much more professional, smarter, stuff like that. But you can just put a break here because I think that's the only loop we're in. We'll try this for now. And then let's move down to options. We'll do the same thing. We press 1. Actually, let's make this 2. Current game state equals menu and break.
Hey, Alan.
Yes.
Do you remember how to add the separate
Recording. Okay, we're going to create a mouse. We have a 50 by 50 mouse image. Now we're going to add a mouse class. Okay. Mouse is a standalone class. It's not going to be derived from anything. It needs SDL, so we will include globals here. in the H file. Not game state, global. Little global. And what does a mouse need? A click?
Or, I'm sorry, just needs an image, just needs a picture.
Needs an image. So SDL underscore texture. Texture. Why is it angry? Okay, because it's slow. But it needs a rectangle. Really, these should be public. I don't know why I put it in private, but the rectangle, you might want a position vector. But something you do want, when you've got a mouse and it's a 50 by 50, you only want collision on one point on that mouse. Otherwise, if your mouse is hovering over two things at once that could be clicked on, and you click, then it doesn't know what to do. It basically clicks both at the same time, and if you're trying to change game states and your mouse is on two buttons, you know, it's not going to crash, but you're going to get undesirable behavior. That's the best way to put it. So we're going to have a 50 by 50 mouse. That will be this rectangle here. And then we're going to have another rectangle, which I'm going to call the point. And that's just going to be a 1 pixel wide mouse, or 1 pixel wide collision point that will actually do the detection of what button we're on or what thing we're clicking. So we need an update function. I think that's it. So use your light bulb to create a definition for the update, and then we'll go fill out the constructor and destructor and so on. Alright, in the constructor we need to load in the image. This is img underscore load texture. And we give it the renderer and the mouse file. If you didn't call yours mouse.png, then now we've got an issue. We need the renderer to load the image, but we don't have the renderer. How do we get it here? Say that again?
You're going to put an SDL renderer pointer ren in the mouse function part of it.
You want to pass it in?
Yeah.
We can do that.
Couldn't you just include game state?
Well, we're going to need the mouse in the game state. So if you do that, you're going to have an infinite loop and your program won't run. You can't include a file in a file that includes that file. And we'll have to change our header file.
So every time it's over the thing, it's gonna just turn into the mouse cursor that we made?
No. Okay, we're going to initialize our rectangles here. Rect equals 50 by 50. And then you can put it wherever you want on the screen. And then the point is going to be a 1 by 1, and that's to prevent it overlapping any two buttons or anything at the same time. And its position will be, wherever you put the cursor. So what this looks like, we've got a 50 by 50 square that's going to actually house our image. And then we're going to put a 1 by 1 up here on the tip that's going to do the contact. That's what that does. Now, if you want your point of contact to be somewhere other than the top left corner, actually we'll modify that in just a second. You'll have to change these numbers. The 1 by 1 is the height and the width, and you want those to stay the same, I think. Let me make sure that's right. I may be wrong. No, I am wrong. X and Y are the first two, and width and height are the second two. So I have it backwards. This will be 300. This will be 300. The width and height will be 50. And the X and Y, sorry, the other will be 1 and 1. I put 300 because that's a guess at the middle of the screen. Not really, but close enough. Maybe somewhere over here. All right, an update. Oh, one other thing we can do here is we can turn the mouse off. So if you don't want the default mouse hovering over your mouse, you can do this show cursor, and we can set that to false. An update, we're going to update our rectangle and update our point to be wherever the mouse is. So to get that information, there's a call get mouse state. And it needs an X and a Y address. So we'll give it the address of our rectangle. And then we'll set our point to match our image. Now, what if I want my point in the middle here? What if I chose to go with like a bullseye looking mouse instead of an arrow, and I want my contact point to be right in the middle of the bullseye? How do I change this code?
Just change the position of the dot.
How?
Change it to 1
Tell me what to type.
Instead of typing 300 to render, you type 00.
No, we put it in the top left corner. It has to be updated. This has to happen every loop. Because if the mouse moves, the point has to move. So it has to happen here. What I have does what I drew originally, but if I want it in the middle, what do I do?
Have to add 25 to it?
Well, add 25. If I add 25 to the X, that's going to scoot me over right here. If I add 25 to the Y, that would bring it down to the middle of that 50 by 50. So that's how you adjust your offset for your point. If you've got some funky mouse cursor, you can do that. If you've got the standard mouse cursor with the point in the top left corner, we just leave it like this.
Praise Jesus, you say what I want.
Okay, we need a draw function too, so we can draw the mouse. So head back over to the H file. And we can define that. This is just going to be a call to the renderer. We'll have to pass that in. What did I do wrong? Capital C. That'll draw the mouse, hopefully. All right, let's test this out. Let's head back over to game state. Should the mouse be static? Do we only want one mouse?
What about 30 mouses?
30 mice. I mean, you could do that. You could have a different mouse with a different image in every state and in a different position. I don't think we should do that. If you want to do that, more power to you, but I'm just going to go with one. Oh, we got to include mouse up here. And then over here in global space, it's important that this happens after you load your window in your renderer, because the mouse needs the renderer. If you try to do the mouse first, this will crash. So we got a mouse pointer from game state, called mouse equals new mouse. And the mouse needs the renderer, so it's important that we send that in. And now, in all of our states, you would call mouse update, and then on all of the draws, you would call mouse draw. And since that would happen in every state, you may want to set up like a general update. But does it really happen in every state? If this is a snake game, you're not going to have a mouse during gameplay. So it's not for every state. So we'll go ahead and it'll be repetitive. Or actually, we just don't have to call the general update in the gameplay. Let's go with that.
What did you say? What did you say you wanted?
I'm thinking because this is going to be repetitive, in every game state you're going to have to call update on the mouse, right? Except for the levels. But in credits we want the mouse, in options we want the mouse, and then the menu we want the mouse. And probably on the win and lose screen you would want the mouse.
So you would just call it for those specific ones?
You just call it once, or just make one call to that. And if it's just the mouse, that's redundant and that's stupid. But if we had other stuff that needed to happen in every state, then we could put it in this general update function.
I see.
See what I'm saying?
Yeah.
It's not right or wrong, it's just kind of a way of optimizing. So up here where we have a void shutdown, let's do a void. I can't call it update because I already have update, so this would be general update. Base update, however you want to think of it. I like base update better. Let's do base. And the base update, right now we're just calling mouse update. But if we have other general stuff we want to do, we can put it in here if it applies to everything. And now in every class, so go to game state CPP, menu update, main loop we will call base update. It might be important as to where we call this. I'm going to do it after the poll event loop. Same thing in options. After the poll event, before we read the keyboard, let's call base update. That may need to change. We may want to move it later, but that's a good starting place. And let's see if we have a mouse. I don't have a mouse.
Yeah.
Oh, we didn't draw it.
Yeah.
Did not draw it. So in menu, first in menu and then in options. It's important that we draw it after we draw the background, right? So you don't draw the background on top of the mouse. Mouse draw and pass it to renderer. And just copy that line and drop it down in options as well.
Does it matter where we put it? Like, does it matter where we put it? I put it like right after the render present.
if you put it here, you're not going to see it.
Yeah.
Because present is going to show the canvas to the screen. And if you draw on the canvas after you present, you're not going to see it. The draw order is important. There, I've got one that works. And it should work in both states. Stays in the same place. It converts back to the Windows cursor when I leave my window, and then it becomes my custom cursor again when I come back to the window. Does that work for anybody else? Good? All right, now we can add buttons. So let's go to add a class. In this particular demo that we're working on, we're going to load in all of the buttons from a single sprite sheet. If you remember the assignment, I've got an example set up at the bottom. So if that's the case, how do we load the texture?
Text.
We're going to have a texture. This will be our sprite sheet.
Don't we need to include anything that's been back before? Is that what we do?
Include what?
Don't we need to include SDL at the top?
We'll bring in globals, and that will bring in SDL. But if I've only got one image, and it has all of the images I need, this is static. Right? There's no reason to load this texture over and over again for every button. I just load it once. And then we can initialize it in button CPP. The only problem is if Visual Studio compiles button first before it does game state, we're going to have a problem because we won't have a renderer. So there's a couple ways to handle that, but I don't know what the best way of handling that is. I guess we can initialize it to null. And then we can load it in the constructor. I think I need to put button there. Anyway, if texture equals, basically you can say if texture, or if no texture, then we'll load it. And then we'll need the renderer and the buttons. What? Problems? We need the renderer here, don't we?
Yeah.
So we'll do the same thing we did with the mouse. And then we'll have to go change the header file so that it also includes the renderer. Alright, for the button class, what else do we need besides the texture?
Button click. Yeah.
We need collision, but collision is more of an action.
Okay.
We need rectangles. We're going to have two rectangles. We have a source and a destination. We have the one on the sprite sheet. So our sprite sheet's going to look like this. And then we'll have our buttons laid out. This will be like start, option, and then we'll have the overstate over here, like if it's highlighted, if it's selected or not. But you have two rectangles. One is on the sprite sheet. It's what do you want off of this sprite sheet? This is called the source rectangle. Maybe we want that guy. So this is the S rect, source rectangle. And then you've got your screen somewhere, your canvas that you're going to draw this thing on. And maybe I want my start button in the middle of the screen, right there. This is the destination rectangle. Does everyone understand the difference in the two? The source is what do you want on the sprite sheet. The destination is where do you want to draw it. If that's confusing, it's okay. Because every time, I'm not going to make that capital, I'm just going to do that. Every time I teach this class, people get that confused. Put on the sprite sheet, on the screen. We may want a Boolean to tell us whether or not these are selected. I don't know for sure if I need this. It kind of depends on how I code it later, but I think we might want that. When we hover over the mouse, it's going to become selected. When the mouse leaves, it will be deselected. So this will flip back and forth from true to false. And the destination, or the source rectangle will change whether or not this is true or false. So we'll have a highlighted state, and then we'll have the base state. Here we go. We'll add those two functions. We'll have a void update. I'm not sure what all update we'll need. And then we will have a draw that will definitely need the renderer. Now when we're using the constructor, if we're going to create a button, we have to pass the renderer, but you may want to pass in the coordinates on the sprite sheet so that it lines up with whatever button you're creating. Otherwise you have to set it in a different function or set it directly. So neither is right or wrong. I just think it's a little cleaner if you do it all in the constructor. So I don't know, this may not be cleaner. Kind of undecided here on what to do. Let's go ahead and we'll do the source. So we'll have this will be the top left corner of a button, and then we'll head over to the source file and modify it to match. So we'll take in the X and Y when we create the button, and we'll set our source rectangle based on those coordinates. And we can also set the height and the width. Now, you may want to pass those in as well, or since all of our buttons have the same height and width, it may be okay just to hard code that. I'm going to hard code it. The height is 64 and the width is 192 based on the instructions in the assignment. And then you can set the position. We can create a function to set the position. So void set position. And then we'll set our destination rectangle inside this function. So urect.x equals x, y is y, width and height will be the same. And then for our draw function, we just have a render copy. This will not be null. This is the source rectangle and the destination rectangle. By reference, by reference. In the update, we need the mouse, right? Because we want to know if a mouse is hovering over the button. So we can come up here and include mouse. And here's how you check for collision. Well, we're gonna have to pass our mouse in when we update our buttons. Or you could pass the buttons into the mouse and update the mouse. Either way. But I think we'll pass the mouse into the buttons here. I've got to change that in the header as well. It means I have to include mouse here, so I shouldn't include it. You shouldn't include it in the source file, I should include it here. Include mouse. Update's going to get a mouse pointer. And in the source file, we don't need to include this. And inside here, we can check and see if our mouse is over a button. And so what you'll do is you'll type if, and there's a function called sdlHasIntersection, and that will check to see if two rectangles are colliding with each other. Has intersection. And you just give it two rectangles. What's the mouse rectangle going to be? Point. Point. That's the part that does the collision. That was the whole purpose in making the point. This has to go in by reference, so don't forget your ampersand. And then what rectangle for our button? What's the one on the screen, the S or the D? Okay, if this happens, it's real simple, selected equals true. Else, selected equals false. There's a bunch of extra letters. Okay. If it is selected, we want to move the source rectangle from the left side of the sprite sheet to the right. Actually, instead of writing a separate if statement, I can do this. I can do this all right here. I'm not going to do plus equals. I'm going to do equals 192. And then else, we'll add curly braces here. That's important. Don't forget your curly braces. We'll need to set it back to the other side. I think this is right. I may be off by one. But I think that's right. That should work. That should be good. Drawing looks good. The setup looks good. We can destroy our texture in the destructor. Alright, let's go to game state. We're going to include button, so we don't need mouse anymore. Mouse will come with button, so you can just change this. To button.h. And for our menu in the constructor, we'll add a button. And in the options, we'll add a menu button. Let's go over to update now. Update our button. Well, we need to initialize it, so menu constructor here, options button equals new button, and we pass it the renderer and the X and the Y. So for options, you need to know where options is. X is going to be 0. That's the far left side, and then on the right side, if your options are your first thing, it will be 0. If it's your second, it will be 64, and so on. I think. And then in the update function, after we do our base update, we'll do our button update. And then update needs the mouse. And then down in the draw, we draw. Where do we draw the buttons? Before or after the background? After we draw the background. Before or after the mouse? Before the mouse, so the mouse can go over the button. And draw against the renderer. Now let's do the same thing in menu. In options. Menu button equals new button. Button gets the renderer and the X and the Y. X is going to be 0. The Y will be, I think mine is the third one down, so 64 times 2 is 128. No, 128. Maybe. Update the mouse or update the button. Use the mouse and draw it. With the renderer. And it crashed and burned. Let's see what happens. I got nothing.
We call it sprite sheet. Right on.
So I did something wrong. Did it work for anybody? Okay. So I definitely did something wrong. So to debug,
Mine doesn't even run. Mine like won't go at all.
then you missed something.
This is not.
What I'm going to do is I'm going to go with the program where I expect my button to be. So that will be in menu, update. I'm going to call options button draw. I'm going to put a breakpoint there. That's this bar on the left. Click on it, you should get a red circle. Now, I'm expecting that button to draw and it's not drawing, so that's why I put the breakpoint there. And I'm going to run this in debug mode. Make sure you do run in debug mode or it won't work. And then when I get here, it's going to stop the program and we can see what's going on. So step in, there's a little arrow up at the top. It says step in. That's going to step into the draw function. And we step over one time. This arrow is indicating where your program is, what's about to happen. Where the arrow is what's going to happen next. So here I can look at my renderer. My renderer is good. If you see null there or you see all zeros, that means you have a bad renderer. We know the renderer is good because the background's drawing. You can look at the texture. If you see letters and numbers there, the texture is probably good. If you see all zeros, that means the texture didn't load right. Look at our rectangle. You can click on this and kind of expand it out. X and Y look good. Height and width look good. And destination rectangle. What does that look like? Can anybody see that? It's on the drawing with the destination rectangle. You can see it down here as well. All this is garbage. So that's why I'm not seeing it. Now the question is, why is it garbage? So I'll stop debugging now. I know somewhere my destination rectangle didn't get set up, and it's because we never called this function. Right, I forgot that. So let's fix it. We want to set it up right after we create it. So in the game state.cpp, Up in the constructor. Set position, and now I just need an X and a Y. So like the center of the screen. How wide is our screen? 1280? That would be 640. But if I set it at 640, that's going to be where it's going to be favoring the right. The top left corner of my button will be at 640. If I want to offset it, I need the half width of the button. So it's 192 divided by 2. Like that. You can straight up do the math right there and be lazy. Or you can punch it in the calculator. So there's our X, and what for the Y? Just pick something for the Y. We can throw 300 in there. You're coming down from the top, however many pixels you want from the top.
What would you say?
This last number is the Y value. So how far from the top of the screen do you want that button? If you put 300, it's going to come down 300 pixels, and that's where it will be. If you think, well, that's not enough, you can put, 5. Just don't go over 720. Actually, if you go to 720, your button's still going to be drawn off the screen. I'll do 500. I'm going to copy this and move it down to our options right after we make the menu button. Make that menu button. And now if I run it, hopefully it will be there. Very good. And it should update. If your mouse hovers over it, should change the image.
My mouse is not moving. Considering my updates on.
The mouse is not moving.
Considering my mouse updates on. What?
So right now we're changing states based on the scan code. We can leave that in there, but we also want it to change if the button is selected. And there is a click. So let's just say after we check for input here, we'll say if options, where am I? I'm in menu. Yeah, I'm in menu. Options button selected. And I need to get a click. A click is an event, so I can't do this here. This will have to happen up here in the poll event. So case SDL mouse button event, or mouse button down is usually bad. You usually want to go on up. No, I don't want curly braces here. This will be any mouse button coming up, but you can specify, if E dot button dot left or something, then we'll get there. But this should work for any mouse button coming up. If options button is selected, we want to change states. So how do we do that down here? With the key press. And then we call break to get out. And I said that might be a bad way to do it. Because up here we're in 2 loops, and brake is not going to get us out of 2 loops. So we'll go ahead and change states. Current state equals options. Do that, but then we need a way to kill this loop. We need a break here. And why is it angry? Oh, I'm out of the switch. I got out of the switch. So if you got out of the switch, you need to move that brace down. Brake will get us out of the switch. We still need out of this loop, which will happen automatically, and then we need to break out of this loop. So I'm going to replace this one with a Boolean called running. And I'm going to want to do that in the other state too. So let's go to GameState.h, and we will add just a basic bool here. Running equals false. And then when we enter this state, running needs to be true. So for enter menu, running equals true. And then whenever we want to change states, we can say running equals false. And we'll do the same thing down in options. In fact, you can copy all of this. Come down here to options. Make sure you're still in the switch. Paste that case in there. Change options to menu. Change options to menu. And we'll set up our running equals true. And then the last thing, this while loop now hinges on running instead of 1 or true or whatever. So put your bool in there. And same thing up above. We'll have to change that while loop to run on that bool instead of on hard-coded 1. All right, let's see if our buttons change our game state. No. Oh, maybe it's because I still had it running.
Mine works.
Ugh. Options, credits. Options, credits. I missed whenever I lined up my button. But yeah, it works. I need to fix that. That works. So what's 128 plus 64? Alfonso, real quick, what is it?
28 plus 64.
Hurry!
180, 190 something, 192.
All right, good job. That works. All right, we have functioning interface. That's it for today.